And we back.
I'm back also. I haven't left. That's it.
I didn't even realize I joined the meeting. I'm like, okay. I thought I was joining the class. Yeah.
Yeah, you can join the office hours. You guys can all join.
I only had one issue with the homework.
Yep, I'm not surprised.
No, I was able to understand all of it except one problem.
Which is?
It was to solve for K. It was, I don't know.
Those are actually easy. The idea is that find the formula for F. I thought I put on Blackboard find a formula. Did I forget that?
I got 3.04. Somebody in the chat said they got 7 for that problem. Because one of the, it's number 11. In the back of the book, it says the answer is 112. But 112 is a function. It's one of the answers.
Oh, to the back of the book is wrong. The back of the book is wrong. We just did it. Yeah. The back of the book is wrong. We can go through that. Yeah. So probably, yeah, don't worry about that. It's not you, it's the back of the book.
Okay, yeah, that was the only one I had a problem with. Everything else was pretty good.
Okay. All right, I mean, I'm waiting for everybody. But the first thing I'm gonna do when it hits 5 is I actually wanna make comments about your quiz.
I forgot to check my grade.
Oh, no, please do, because I try to send comments as well.
Do we have a quiz today?
No, Wednesday.
I don't know, you answered this question. I'm not answering. Unless you want one, I can do that.
You be cooking this, man.
Bro. Oh, that's funny.
Okay. All right, we start. It's 5 o'clock. And I need a sip of coffee, sorry. Okay.
Me too.
All right. Before we start, take up your questions and everything. And you guys put on the chat the problems you had trouble with, because we're going to do that. I'd like to make some comments about your quiz. What went wrong and what didn't go wrong.
Yeah.
What went wrong is, some of you are not using the quadratic formula correctly. So if I take the quiz, I mean, the solution is on Blackboard, so I will not really do the whole thing. So my function was, so I'm looking at the quiz. So this is problem number 1 on the quiz. And my function was x squared plus 10x minus 12. Okay, and the question was find the zeros. It means we have to set f of x equal to 0. So as I am working, I tell you what mistake I encountered. X equal to 0. And we cannot really factor this even if we try. So we use the quadratic formula and let's see how it works. So first A is 1, B is 10, and C is minus 12. We start by identifying those. And the quadratic tells me you have 2 solutions. Minus B plus. And a lot of students put times. It's not a multiplied by, it's adding. The square root of B squared minus 4AC over 2A and minus b minus. So the first mistake that came up was some student, actually more than one, instead of putting a plus and a minus, they just multiply them.
Instead of writing it out 2 times, can we do the same, write out the equation, then do a plus and then a minus under the plus? Can we do that as well?
Yes, you can do that. Yes,
okay.
Absolutely. And I think I don't know if I did that. I do it this way just to remind you that you have 2 of them.
Right.
Please unmute if there is noise in the background. All right, so now we just have to compute. So b squared, I compute b squared minus 4ac because that's the common term. And you have to identify those. So it's 10 squared minus 4 times 1 minus 12. So if we do the math correctly, which is a lot of you did, you're not gonna get 148. So my solution would be, and as I said, you can put plus or minus. It's absolutely correct. Minus b, it means minus 10 plus the square root of 148 over 2. And minus 10 minus over 2. All right? So please, when I'm doing this, it will be very helpful to you to put the quiz in front of you so you can compare your mistake, because I'm addressing the mistake that already occurred in class. All right, so far so good. Some student actually gave me an approximation, which is fine, and some students pushed themselves nicely, and I like what they did, but I have to correct what they did. So some students took the quantity square root of 148, and they said square root of 148, this is basically 4 times 37. So they actually split it up, and actually if you take 4 times that, you got 148. And then they wrote this as the square root of 4 times the square root of 37, which is 2 times the square root of 37, which was very nice. So now the solution will become minus 10 plus, instead of the square root of 48, the student put square root of 37 divided by 2. The only mistake that happened, that some students simplify this 2 and this 2. Is this a correct mathematical operation?
No.
That's the mistake that showed up. You can't simplify this 2 and this 2. That's absolutely wrong. You can only simplify if you have 2 times something over 2. It has to be a multiplication. That's when you can simplify. You cannot simplify in this scenario. So some student gave me, I forgot, minus, I don't know what they gave me, minus 10 plus the square root of 37, because they simplify, which is absolutely not correct.
I think I had that in a decimal format. Is that okay?
Yeah, I did say it is okay. I did
Okay.
say it is okay, but some students are pushing themselves in the right direction, and I definitely like it. It's actually very nice, but I have to correct their mistake. So now the best way to do it here is, one way you can say it's minus 10 over 2 plus 2 over 2, which is gonna be minus 5 plus the square root of 37. Okay, so that was the first problem. Is that very clear?
Wait,
Yeah.
I thought you couldn't divide the 2 that's next to the 37. Oh, wait. Yeah, you can.
I
Never mind.
split it now.
Yeah, you did. I see.
I split. Now the math is correct. Now I can simplify, because I have 2 times something over 2. I don't have 2 plus something, but that's when I cannot simplify. So I cannot simplify if I have this scenario. Sorry, I can't simplify. That's absolute nonsense.
Okay.
It's like saying 2 plus 1 over 2. You cannot simplify 2 and 2 and gives me 1. It's wrong.
Yeah.
2 plus 1 over 2 is 3/2. The only time you can simplify if you have 2 times over 2.
Right.
That's when you can simplify.
Okay, so their actual mistake was that they didn't divide the 10 by 2 also.
Right.
They only divided by 2.
Exactly. Every term has to be divided by 2. So
Okay.
we have to be very careful. We cannot simplify those 2. That's a bad algebra mistake. So that's really a mistake that occurred in the first quiz, and I wanted to address it. The other mistake is some of you forgot the relationship between growth rate and growth factor. So always, that's the relationship. It's not hard. The growth factor is 1 plus the growth rate. That's the relationship between them. So in problem number 2, let's see part B, because I'm not going to do all of them. So my function if f was 20 times 0.23 to the power t. So here, initial value is a. The growth factor, which is the b, that's the growth factor. That's the 0.23. That's the growth factor. Now, what's the growth rate? I use the relationship between them, which tell me that the 0.23, which is the growth factor, is 1 plus the growth rate.
I see where I went wrong.
What?
I see where I went wrong. I subtracted for some reason instead of adding.
So the growth factor is good. The growth rate is going to be, no, I don't think, no, I forgot. I don't know. You got to try. 0.23 minus 1. I think you got to try.
Okay.
I think. I don't know. Which is 0.77. That's the growth rate. Means how far we are from 1. It means minus 77%.
Oh, I got it right. Okay.
Yeah, I remember that. Okay. All right. So I don't know what other comments about it. So that really was an important comment. And you guys see the solution. Another mistake that a lot of students messed up on 0.9%. They did not write it correctly in decimal notation. 0.9% is just 0.9 over 100.
I was
So
confused with that one. I thought it was like 90, or is it like 0.09?
It's 0.9%. What means? It means 0.9, it's less than 1%. So it means 0.9 over 100.
Okay, no wonder. So it's 1.009, not 1.09.
That's the growth factor. Yes.
Yeah.
Yeah. So the growth factor here is 1.009. It's 1 plus your growth rate.
Right.
Okay, and a lot of students messed up at this stage.
Yeah.
Okay, so this is the comment about the quiz, and any other comment, you guys have it. So please make sure you read it and go over the solution. So that's the only way you're gonna learn this material. All right, now I go to the homework, and then I will go, I'll go back and start the new stuff. So please write your homework, the questions you have on the chat, or say them, and I will proceed.
Number 11 from the book.
Number 11 from the book. Okay, let's do number 11, the way it is in the book. So the way it is in the book was like that. They gave us the following table. They tell us you have a function which is exponential, x f of x. They told me I don't know what it is at 0. At 1, it's 14. And at 4, it's taking the value 112. And they want me to find k. And the way we're going to do this problem is actually, I think I mentioned that on Blackboard. The way I want you to do it is find a formula for f. And then we find the k. So when I find a formula for f. For f. All right, what is f? F is an exponential. They told me. What does it mean exponential to you? It means the formula has the form a constant a times b to the x. That's how it is. And to find a formula, it means I need to find a and I need to find b. It's like linear. If you have a linear function, the form is mx plus b. And finding a formula for linear, you have to find the m and you have to find the b. So finding a formula for the exponential, you have to find the a and the b. Now, to be able to find a and b, they should give you, so you have two unknowns, it should give you two data points. And I have my data points. So how do I read this thing? I read it like that. This is a function that takes 1 to 14. And my function takes 4 to 112. Means if I am actually starting to graph this function, graph it, and you're going to be talking more and more about the graph, it takes 1 to 14, and it takes 4 to a lot, 112. And so this is really my function, basically is something like that. And our question is find f of 0. But I cannot find it unless I find a formula. So I know what f of 0 is. So let's see how to find a formula. And that's something we did in class. And of course, I'm going to do. If f takes 1 to 14, what does this mean? It means if I take a multiplied by b to the power 1, I get 14.
I have not forgotten anything that's
Please. Okay. And this tells me if I take a times b to the power 4 is equal to 112. That's how we read this information. I need to find a and I need to find b. Okay, how do we do that? You guys remember?
You have to solve for a.
We're gonna solve for a from the first equation and plug it into the second and get going. So the first equation tells me that a is 14 over b. And then I'm gonna plug it in the second one. So I have a times b to the power 4 equal 112, but a is 14 over b. It means instead of a here, I have 14 over b times b to the 4 is 112. I'm multiplying two quantities. This is like over 1. It means 14 b to the 4 over b is equal to 12. Remember here we're multiplying. So b4 over b is going to give me b to the power 3 is 112. Means b to the power 3 is 112 over 14, which is equal to 8. So b to the 3 is 8. It means my b is the cubic root of 8, which is equal to 2. So now I have one piece of the puzzle. I have the b, but a is easy. A is 14 over b. So I have b is equal to 2, but a is 14 over b. This is my b, but a is 14 over b. It means 14 over 2, which is equal to 7. So my function is 7 times b, 2 to the x. Now I know everything about it. So now the problem is asking me to find it at 0. So the problem wants me to find it at 0, and we're going to find it at 0. Because what is k in the problem? K in the problem is the output at 0. That's the k. So it's times 2 to the 0, which is 1. This is equal to 7. All right?
Yes, ma'am.
Okay.
I got it wrong because I put 4 instead of 14 when I wrote it down.
That's no problem. No issue with that. Please, you have any, how did the worksheet go? Did you guys work on it?
I did the first one, A, and I don't think I did it right. I got a really big number in the calculator.
Okay, so I'm gonna pick up the worksheet if I can find it. I thought I put it in front of me. Sorry, guys. Okay, here it is. So I'm gonna do the first problem, and then I will write up the solution to the other two so you guys can check your work. All right, so let us do the first problem, which is exactly what I've been doing there, but the numbers are a little bit nasty. Nasty.
So if the numbers are nasty, I probably got it right.
All right, so let us do that. So my first problem, actually, I set it up the way I'm doing it. I told you that I want the function at 3 to take the value 3/8. And at 7, I want my function to take the value 12 and find a formula. So that's an exponential function. And at 3, so it means if my input is 3, I want my output to be 3/8. So 3/8 is a tiny number. It's, very tiny. It's less than 1. And at 7, I want it to jump all the way up here to take the value. So this is 3/8, and that's 7/12. So my function is moving like that and like this. That's how it's gonna look like. And my question is, find a formula. Again, every exponential, it means every function that grows by the same percent, that's exponential. Very specific kind of growth is a times b to the x. And the rest is going to be algebra. So what is f of 3 equal 3/8 tells me? Tells me if I take a times it with b to the power 3, means I plug in 3 for x, I'm going to get 3/8. And f of 7 equal to 12 tells me if I take a times it with b to the power 7, I am going to end up with 12. And now the question is solve. So I'm going to solve it the way you guys are comfortable with. I'm going to pick up a in the first problem. Solve for a in terms of b. So what do I get? How can I solve for a in terms of b?
I had got a equals 3/8 divided by b to b cubed. But my question was, can I do 3/8 times b cubed over 1?
Repeat a little bit. So let me write what I understood. What I understood from you is 3/8 over b squared.
Right. Can I rewrite it into b cubed?
Sorry, yes.
Can you rewrite it as 3/8 times b cubed over 1?
Absolutely. Okay.
You know what I'm saying?
3 over. Is that what you said?
Yes. Yeah.
Okay, but this is nasty still, right?
Right.
Right.
Excuse me, Professor?
Yeah, I'm listening, Sam.
Patrick Jones, can you mute your mic? Because your name keep popping up and I can't see the screen unless you mute your mic. Thank you.
There's a button you can press on, go to the instructor's name. There's 3 dots, press that and press pin video. And then her video will stay up.
Thanks.
Did you understand, Sam?
Yes, thank you.
Sure. Now, let's go back to this. And this is really nasty. I'm not going to keep it like this. But how do we divide this? Times 1 over b cubed.
Yeah.
That's the way you should do it. And now how do you multiply? 3 times 1 is 3.
Yeah.
Over 8 b cubed.
Can we do it that way too?
You have to.
Okay.
Or the math will be problematic.
Yeah, that's why I was getting a weird number because I
Yes.
didn't know what way to do it. And
You have to do it, otherwise it will be problematic. You don't know how to work with it algebraically.
okay.
Okay, so this is gonna give me, so now this saves me a step. It means a is gonna be 3/8b to the power 3. Now it's nice, it looks very well. Okay, now I have AB7, so I'm gonna plug this a back into here. So we have a times b to the power 7 equal to 12. But a is 3/8b to the power 3.
Right.
So now I'm going to plug it in. It's a little bit of algebra, but it's a very good algebra for us. Times b to the 7 equal to 12. Now, how do we multiply fraction? I said it several times. You just multiply numerator. So I'm going to have 3b to the 7 over 8b to the 3 equal to 12. Are you all with me?
Yep.
Now, b to the 7 over b to the 3, it's all multiplication. You're going to have how many b's left in the top?
4.
7
4.
minus 3. Because you have b7. And so how you look at it, you even memorize it's 7 minus 3. Or what's 3b7 or b3? It means 3b times b times b times b times b times b 7 times. 1, 2, 3, 4, 5, 6, 7. Right? Over b times b times b 3 times. That's really what the picture is. So how many b's are left?
4.
4. It's 7 minus 3. So you're going to 3 be 4 over 8 equal to 12. It's still not very pretty, but we're getting there. Now I want you to tell me, how can you isolate b to the 4?
Times by 8/3.
Did you guys follow what she said?
Multiply by 8/3 by the reciprocal.
Multiply by 8 both sides. I got rid of that.
Oh.
Oh, yeah.
You're absolutely correct, Roxanne, but Anna, let me do it a bit slower. Okay, I multiply by 8. If I multiply 8 here, I get rid of my first 8. The problem is easier. And then I divide by 3. Over 3. So finally, b4 is equal to what? This is a nice number. This is actually a very nice number. And how much this number is?
96
Can you guys
over,
tell me? It should be how much?
96 over 3.
Okay, which is?
Which is 32.
Which is 32. So if you compute this number, you get actually 32. It means, what is my b? It's the 4th root
Of 32.
of 32. Don't be afraid of that. It's the 4th root of 32. And we're almost done. So we're almost kind of done. So b is the 4th root of 32. Now, is the 4th root of 32 a nice number?
No.
No? Okay, so I'm going to pick up my calculator.
It
and
was
I'm going to compute it.
like 2.35 is what I got.
Okay,
when I rounded
32 to the power 1 over 4. And I'm getting
7.
2.378. I'm finding my numbers up to 3 decimal places.
Can you
So
do that
now-
one more time, please? How you put in the computer?
Okay,
Just to, I like looking
the
at
way I do it, I raise it to the power 1/4. Okay, so I'll write it down.
Okay.
Interesting.
This is nothing more than 32 raised to the power 1/4, because that's what fractional exponent means. So how do we raise to the power 1/4? Can you see my calculator?
Yeah.
32 to the power, open parenthesis, plug in 1/4.
Oh, gotcha.
5.
Then you get 2.378. That's fraction exponent. The 4th root is to the power 1/4. So now I have A. Finally, I want, that's my B. Now I need my A. What is my A? I go back to the relationship that existed between them. It's 3 over 8 times B cubed.
Mm-hmm.
And it's 3 over 8 times 2.378 to the power 3. So it's,
Yeah.
as I said, it is nasty, but that's all right.
Yeah, it's very nasty.
Now, let us compute that. Let's compute that. 3 in the numerator. Let's compute the denominator. So you guys use a calculator at the same time I'm doing it. Times 2. Okay, I'll show you how I'm doing it. I'm looking at the denominator. It's 8 times, I open my parenthesis, My b is 378 to the power 3. So that's my denominator. So I'm getting 107 times 57. And now I need 3 over. Now, there is one trick. If you want to pick up the previous number, you can, my calculator, you can do the following. Second answer. Then it will enter the answers without having to do anything. So I'm getting 0.0278.
Hold up. I got like 32 point something. Hold on. Give me 1 second while I plug this in.
Okay, I'll give you 1 minute because we have to move on.
Yeah, I got you.
Anybody, please, I want everybody to be working with me so we can find out. So finally, my f of x is my a.
I got it.
Times my b to the power x. And of the problem.
So that's your a, right? Okay. Boom.
But that's my a.
So I lost internet there at the beginning, but we were just supposed to use a calculator and then round.
Yes, that's the easiest way out. Yeah.
Okay, because I ended up with a really complicated fraction at the end, which I just did on the calculator, and I got the 0.278. So
right. Yeah. That's the easiest way. I mean, I can tell you how to do it by keeping it fraction, but that's all right for now. We can do it this way.
That's what I did.
Yeah. It'll become, if you do it keeping fraction, you will actually get the same answer, of course, but I don't know if this would help you. This has to be the same. And this term, one way, if you don't follow, don't worry, you get x over 4.
Please don't put this on the quiz. This one was complicated.
No. All right?
It's going to be on there.
And any other question before we move on? And it says that you guys do the worksheet. I will put the solution on Blackboard. But I think it's good. It's good that we are able to do that. But you have to do those problems. Please do those problems. What time is it now? It's 5:30. Okay. I will have to start the new material today, which is, of course, it's all related to that, but with a little bit of a different point of view. So what we're going to do today is we studied 3 types of functions. Linear, that have the form mx plus b, and quadratic, I'm not going to worry about the quadratic in this part, and exponential. And in this section, we're actually going to compare how linear grow versus how exponential grow. Now, exponential, we know one thing about it, is that if a quantity grow by the same percent every year or every day or every hour or every minute, then we figured out previously how to find a formula. Today, we're going to have another way of looking at the b. We're going to try to understand the b more. So the goal today is to compare those 2 functions and understand the b. But before I do that, I'm going to take you back to linear. And remember, what is the formula for linear? And what's the meaning of every piece in linear function? So remember, linear, the graph is a line, and they have the form mx plus b. Sorry, I wrote them backward. So m is 5, and the b is 4. And let us remember what the m and the b represent if you have a linear function. All right, I just plugged in some values here to make things easier. The 4 represented what in the linear? Linear is a plus, remember. Exponential is multiplication. We're going to get to that. So 4 is what? Is the output at 0. 4 is my intercept in this case. And how does linear function work? What does the m represent? So if I take x, 0, 1, 2, 3, so I'm letting x increase by 1, then here I have the output value. So if x is 0, it's 4. If x is 1, it's 9. I'm plugging 1. If x is 2, it's 14. If x is 3, is 19. What happened in linear function? When x increases by 1, by how much the output increases by? Okay?
By 5.
Guys,
Yeah.
remember, by 5. From 4 to 9 by 5. So the
It's
input
consistent.
increases by 1. It's a constant rate by 5. That increases by 1 again. Output increases by 5. The y values increase by 5. That's my slope. That's what my slope is. X increases by 1.
Oh.
The y value increases by 5. So every time in a linear function, when x increases by 1, then 5, the constant number 5 is always added to the y value.
Right.
Graphically, increase by 1, we add 5. Increase by 1, my output adding 5. So that's how linear behave. So in general, if f of x equal mx plus b, regardless when we start, that's important, regardless when we start, we increase by 1, the input or the output increases by m. If m is positive, if the slope is negative, we're going to go down and the function is decreased. So in a linear function, increase by 1, the y value increased by m, which is the slope. Now we're going to take the exponential function. And that's the one that you want to try to understand well. All right. How does exponential function behave? Now there is definitely very different formulas. Linear, remember, we're taking 4, that's the b, and we add mx, which is 5x. That's the linear scenario. Exponential, I'm going to give you the following function. It's 4, we multiply it, it's very different, by 5 to the x. So very different, actually, formula. But let us have a look at it and try to understand it a little bit more. I'm going to let x increase by 1, and I'm going to ask myself, if x increased by 1, what's happening to the y value?
They're multiplying.
It's going to be multiplied. If x is 0, it's 4, right?
Mhm.
If x is 1, what is f? 4 times 5 to the power 1
20.
is 4 times 5. So what happened from here to here? It's the original value, you multiply it by 5. That's 4 times 5.
20.
I don't care about the answer now.
Oh,
I don't care. Now, I'm going to let x increase from 1 to 2. What happened to the y value? It's multiplied by 5. Because if x is 2, what is f of x? F of x is 4 times 5 squared, if x is 2. But how is it related to the previous value? It's basically 4, the previous value is 4 times 5. At 2 is 5 squared. But what is 5 squared? It's 4 times 5, the previous one, times 5. So from 1 to 2, you actually multiplied by 5. So from 0 to 1, you multiply by 5. That's the output at 1. Output at 2 is 5 times 5 squared. You multiply by another 5. From 2 to 3, it's the same pattern continuing.
yes.
Are you multiplying the previous value by 5? Absolutely, because what is f of 3? Let me write it in big so you know exactly what is f of 3. F of 3 is 4 times 5 to the power 3. It means 4 times 5 times 5 times 5. This piece, that's the 5 squared times 5. This
Right.
is what it was at 2. You multiply it by 5, you're getting what it was at 3. And that's crucial. So how does exponential work? When x increases by 1, the 1 is important. What happened to the y values? They are multiplied by 5. What's the 5 here? That's the growth factor.
Oh.
That's my growth factor, not rate, factor, my growth factor. So every time we increase by 1, my y values are multiplied by my growth factor of 5. 1 multiplied by 5. 1 multiplied by 5. But in linear, what happened? What's the difference?
Addition.
We're adding 5 every time. So we're adding a constant number every time. Here, we are multiplying by 5 every time. It means whatever the output was, the second one, the new one after 1 unit, is the old one multiplied by 5. It's growing fast because we're multiplying by 5. So graphically, it's really growing very, very fast because what is going on graphically in this particular scenario? What's happening here is the following. It's starting at 4. And after 1 unit, we're multiplying the 4 by 5. So after 1 unit, this is multiplied by 5, which is going to give me the 20. After another 2 units, what's happening? This number is becoming multiplied by 5. It's 5. Every time you multiply by 5, which is 2, 100. Is this function going to grow very fast or very slow? What do you think?
Fast.
Very fast. Because every time you're multiplying the y value by 5. So every time, so if it's 4, it's 20 after 1 unit. It's 100 after 2 units. What's going to be after 3 units? You multiply this
500.
output by 5. It's going to be 500. It's function which is growing very, very, very fast. And unfortunately, if you guys watch the graph of the coronavirus right now, it's growing exponentially per day. So if you see the graph is really going like that at this moment. And the hope is it stop this exponential growth and start going down. But it is actually right now a very bad growth because it's in exponential growth. I don't know what the factor is, but I think those who are studying this stuff know by what we are multiplying. It's a very, very bad growth because it's an exponential growth. All right, so that's really what exponential is. So when x increases by 1, the y value is multiplied by 5. And that's help us understand very well the exponential growth. So here is my formula in general though. So if f of x is a times b to the x, the growth factor is b, then when x increases by 1, the y value is multiplied by the growth factor. Every time x increases by 1, the 1 is important, we're multiplying by b. I start from a, multiplied by b is a times b, that's at 1. Multiplied by another b, ab squared, that's at 2, and so on and so forth. So I decided to give you one more example, and then we start playing with some problems. So another example is this one. So we're going to look at another example. F of x is 7 times a half to the power x. What is my growth factor here? My growth factor is a half. That's the growth factor. My growth factor is a half. How does this function behave? According to what I've been talking about, how does this function behave? At 0, it's 7, right?
Mm-hmm.
Okay, Roxanne is only the one telling me, What about the rest of the class? Are you with me?
They're all muted.
Okay.
No, I'm here. I'm just listening.
Okay. When x increases by 1, what's happening to the output value? This is 7 times a half to the power 1. So what happened from here to here? What did we multiply by?
Half.
Multiplied by half. Is this function increasing or decreasing?
Decreasing.
Immediately decreasing, because every time I'm multiplying by a number which is definitely less than 1. So when you take anything, you multiply it by a number less than 1, the number is gonna get smaller. So if the factor was 1/4, I'll be multiplying by 1/4. So by multiplying by 1/4, I'm making the number less and less and less. So my function is gonna start, decreasing. Okay, increase by 1. My output is gonna be multiplied by a half. So whatever it was, it's gonna multiply by a half. So this function, what's doing is actually halving the value. You start by 7, after 1 unit is half of what you have. Another unit, half of what you had after 1 unit, and so on and so forth. So because my growth factor is less than 1, the output is always multiplied by a number less than 1. It means my function is actually going to decrease in this scenario. So let me explain a little, not explain, let me repeat what I said. So this is my function, 7 to the power ax. So how is this function behaving? Here it is. It's starting at 7, at 0. At 1, the output at 1, in this particular scenario, whatever the output at 0, you multiply it by a half. It means 7/2. So 7/2, it means we are right there. 1 is 7 times a half. 7 times a half is the same thing as 7/2. So you're halving this. After 2 units, you're taking half of that. So whatever this is, you're actually taking it half of it. Every time you multiply.
Is that her screen?
I think she
I
froze.
think so.
Yeah, she froze.
Yeah, mine is saying internet.
I thought it was mine.
No, mine, but it's fine. Let's hope it stays fine. So it's 7/2, half of 7/2. It means you're taking 7/2 and you're multiplying. That's gonna give me 7/4. So having. Okay,
I
guys.
just go to the Amazon website, right?
Okay.
Oh, wait,
Yeah.
she's back.
She's back. She's back.
I'm back. I'm very sorry about that. There's nothing I can do about it. So what's happening here? Because I'm multiplying by a number less than 1, my function is gonna decrease. Will it ever take negative value?
No.
Never. Because every time you're multiplying it by a half, there is no way you can make it take a negative value. It's gonna be always positive, but it's gonna become very, very small. Because every time half of what you had, half what you had, half what you have, it's gonna be smaller and smaller. So before we go back to the lecture, let me talk a few words about the graph of the exponential, how it's gonna look like. Because it fits very much into what we're doing. So the graph of the exponential, a times b to the x, and here a is, I'm gonna assume a positive, and if a negative, I'll worry about it later on. How is gonna be the graph? It's gonna be depending on the b. When b is bigger than 1, it means you're always multiplying by a number larger than 1, the graph is gonna be increasing. When b less than 1, it means your output is always multiplied by a number less than 1. When x increased by 1, it's going to be decreased. And that's how the graph is going to be split into pieces. So let's go back to what you were doing. So the main idea is, if a function is exponential, then whenever we increase the input by 1, the y values are multiplied, and that's crucial, by the growth factor. So now the question is, each of the graph below, and I'm going to put the graph in bigger, of course, is either the graph of an exponential or linear. And in this particular problem, without determining a formula for f and g, determine k. So in those particular problem, I want you to find k without actually finding a formula. You can do it finding a formula, but this time I don't want you to do that. So I'm gonna sketch both function a little bit. If you guys have the notes in front of you, and if you don't, I'm gonna sketch both function, the first one, and I'm gonna give you the data. So the data I have 1, 2, 2, 4, 3, okay, that's 1. And the second one, I will write it and then we discuss it. The second one is this one. And the first problem is easy. Give me 1 second and I will add 3K. All right. These are my problem, very simple. And I want you to tell me what's the K. Question number 1, is this function linear or exponential?
Linear.
Linear. The graph is a line, end of the story. What is the K without finding a formula? I know I can find a formula. I have 2 points.
6.
Can we find it a formula? Okay, I gave you very, very specific value here. At 1, it's 2. That's linear, crucial. At 2, it's 4. At 3, what's K? Because linear, from 1 to 2, it increased by 1. That's increasing by 2. So increase by 1. This should increase by 2. So my K should be 4 plus 2. My K should be 6. All right? Now the second one. This is definitely exponential function. The graph is not a line, and that's an exponential function in this particular case. And then what am I giving you? X, f of x. 1, 2, 2, 4, 3, K. So since exponential, as we go from here to here, we're going to ask myself, by what number is this multiplied by?
2.
By 2. So that's a very easy scenario to understand the picture. So if we go by 1 from here, this should be multiplied by 2. So what should be K?
8.
8. Okay? And actually, what's the difference here? The first 2 values, that's linear. Both functions have the same value at 1 and at 2. 2, 4, 1. Take 1 to 2, 2 to 4. 1 to 2, 2 to 4. So the other function is actually like this. But then when we hit 3, the exponential takes larger value than the linear. The exponential grows way, way, way faster. All right, now I want you guys to take over a little bit, and we're gonna do as a class the following 2 problems. Can you see anything?
No, it's not clear.
It's not clear? Okay.
We can't make out the numbers.
All right, I will write up the numbers. So we're gonna do the first 2. I thought I will. Okay, the first one is linear, and the numbers are 1, 3. Sorry, I will graph it again. So the numbers are 1, 3, 2, 1/2. And I want you to find 3K. So I want you to find K. That's in the linear scenario. All right? So if I put the values, which actually make it clear easier, x, f of x, 1, 3, 2, 1/2, 3K. So that's the linear scenario. So it's not hard. I want you all to do it, and I want an answer not from Roxanne, from somebody else.
-2.
-2. Who agree with? Okay, put on the chat if you agree, or if you don't know anything. Put on the chat if you don't want to talk. I agree. Okay, agree. Very good. So we go by 1. And we're actually going down here by, how much we're going down here by?
Negative
So a half minus 3 by minus 5 halves. Am I right?
Mhm.
We go by 1. We're going to go down by minus 5 halves. So K is a half, but I'm going down by minus half. It's minus 2. Linear. Very easy. By 1, the whole thing through. All right. The second one is exponential. And I'm going to give you the value. And you guys will have to tell me the number. So I put the value because you can't read them. So these are my values. X, f of x, 1, 2, 3. I'm keeping the increase by 1. And this is a 4, this is a 2, and this is a k. Again, that's another easy one. Because I want you to see the picture before I give you slightly harder. So that's exponential. Means when we increase by 1, what's going to happen?
The answer is 1.
Answer is 1. Do you agree with her?
Yes.
Yep.
So we're multiplying by a half. That's easy. We multiply it by a half. So K here, the previous value times the half, which is 1. Is the previous value times the growth factor. That's what is really happening. So the growth factor here is going to be the half. All right, now I have the following problem. Again, it's exponential. Instead of putting the graph, I'm going to put the values because it's actually the same thing. So my values are the following. X, f of x. 2, I'm sending it to 5. 3, I'm sending it to 7. 4, I'm sending it to k. And that's exponential. And my question is, I don't know, find k. So I'm going by 1 every time because we have to go by the same and by 1 to get the multipliers here. And if you go by 2, I'll mention it in a second what's the story. So now I want you guys to figure out what are we multiplying by. So I want to figure out this. And then we find a way to figure it out. So I'll give you a minute to think, and then we find a mechanism, you know, to figure this out. Okay. Anybody have any idea?
7/5 is the
7/5. Okay,
Yeah.
let's 7/5. Now let us figure out the mechanism to find it. So what are we looking for? We're asking ourselves 5 times what equal to 7? You see how I'm thinking about it? 5 times what? So this is the what here. Give me 7. So how can I, what?
Don't you need to like figure out what your A is and go from there?
I did it that way.
That's the way I was thinking.
I
Unless
did the formula.
Yes, let me answer the question. The answer is yes. But in this particular problem, my question is to find K without finding the formula. Is that very clear?
Yeah.
Yeah, I will be very clear in my question. If I want you to find the formula, I will tell you find a formula. If I don't want you to find a formula, I'll tell you find K without finding the formula. But if we found the formula, we're going to get the same answer anyway. But now my goal is for us to understand clearly how exponential behave. That's really the goal of those practice problems. All right, so what is the question mark?
7/5.
7/5. That's how we find this question mark. So this is going to be 7/5. Increase by 1.
14.
Means we have to multiply by 7/5. So what is my K? Is the previous value. You multiply it,
49/5.
which is equal exactly 49/5. Now, if we had to find a formula, we're going to get exactly the same thing. And most of the time, I will ask to find the formula, but now I wanted to understand clearly how exponential behave, because that's important. When you guys see exponential, you should understand it means that every time the input increases by 1, my output is multiplied by the same number, multiplied by the same number. So you understand better and better exponential growth. All right, my last problems be with those ideas, so everybody will be, is the following. This is my data. So those aren't hard, but they are essential to understand the behavior of exponential. Again, that's exponential, not linear. 1, 1/3, 2, 1/2, 3, K. Again, that's exponential. And I'm letting X increases by 1. I'm letting X increases by 1. And if it's exponential, when X increases by 1, actually the Y value increased by, that's the growth factor. That's what they increase by.
6.
6. I don't know. She's faster than me. Do you agree with her?
Yep.
Look, if we don't know, okay. My question is, a third times what will give me a half? So you don't always have to guess. You ask yourself, what should I multiply a third by to give me a half? Means we have to solve for that. How do we solve for it? We multiply by 3 both sides. So I multiply by 3 both sides.
Did I get that wrong?
I think so.
Yeah, you did. If that was 6, that would be 2. That would come out to.
Right. If you multiply 1/3 by 6, Patrick is absolutely correct. 1/3 times 6 is going to give you a 2.
Oh, yeah, 2 and that 1/2.
Okay. So if I multiply by 3 both sides, I will get a half times 3. It means 3 halves.
I did the same thing, Roxanne.
So that's why I am slow. So I multiply by 3 halves. So from here to here, I multiply by 3 halves. So what is my K? It's the
2.
previous value multiplied by 3 halves.
3/4.
It's 3/4.
Oh
If
my
you had
God. And why am I adding?
If you had found a formula for F using what we've learned previously, you will get also exactly 3/4. But the point here, I repeat several times, is to understand the behavior of the exponential. When input increased by 1, not 2, 1 for now, the output increases by, the output is multiplied by the same number, and this is the growth factor. That's the growth factor. That's, so when increased by 1, that's the B of the formula. All right. So the question now, what if we increase by 2?
Increase what?
F will be multiplied by what? I don't know. Suppose I have a linear function. So I'm going to take you back for linear. And suppose f of x is, you know, whatever, the one I started with, 1 plus 5x. And I let x increase by 2. So 0, 2, 4, 6. The output will increase by what? So that's my function. That's linear. If I go by 2, by how much we rise to get back on the graph?
By I don't know how much, but the slope times 2.
The slope times 2. The slope is 5 in this problem.
Oh, then 5 times 2.
So we're going to go up by twice the slope. Because every unit, we go by 5. Another unit, we go by another 5. So it's twice times the slope. So from here to here, we're going to go 2 times the slope. So if you go by 2, we go by 2 times the slope. If you go by 3, we go 2 times the slope, 3 times the slope, and so on. So it's 2 times 5, 2 times 5, 2 times 5. What happens if we have exponential? So if x increases by 2, what happened for the exponential function? Can anybody give me a wild guess?
It's going to be squared instead of multiplied.
It's going to be squared instead of 2 times. So suppose I take 4 times 5 to the x. And I increase by 2. 0, 1, sorry, 2. 4, 6. This is 4. This is 4 times 5 to which power? X is 2, 5 squared. So we multiply by basically b squared. So if we increase by 2, we multiply by b squared. Increase by another 2, that's 5 to the power 4. But what's 5 to the power 4? It's the previous value times 5 squared. So it means from here to here, you again multiplying by 5 squared. It means b squared. And the same story here, which is b squared. So if you have an exponential, if you increase by 2 every time, the y value is multiplied by b squared. B squared, b squared, the growth factor squared. And the picture goes on. If you increase by 3, the growth factor will go up by b to the power 3. That's how exponential behaves. But at least for me, the one to focus on is that when you go by 1, the y value is multiplied by b. It's very crucial to basically understand this piece of the problem. All right. So this is summarized, actually. This is very written here for you in the notes. So if f of x equal a times b to fx, and f is exponential, then when x increases by 1, the y value is multiplied by b, the growth factor. However, if x increases by 2, the y value multiplies by b squared. If x increases by 3, the y value multiplied by b to the power 3, and so on and so forth. Right. So I think we're going to do today is, again, I want you to do the following problem, and we're going to do it together. And here I'm going to take 2 populations, like turtle population, and I'm going to take 2 scenarios. Scenario 1 is assume the growth is linear, find a formula. Scenario 2, assume it's exponential, find a formula. And question number 3, we will get to it, it's not very hard. So I will put up the numbers very clearly for you. So I said at t equal to 0, a species of turtle is released in the wetland. Let f of t be the function that is assigned to t, the turtle population t years after they were released. So you have a bunch of turtles, a biologist put them in the wetland, and he wants to study how the population is growing. So I didn't give you the initial value, but I told you after 4 years, there were 300 turtles, and after 7, there were 450 turtles. My question number 1 is, assume the growth of the turtle is linear. Find a formula for f of t. I give you 3 minutes to do it, and then I will take over. get going. This is a good reminder, good a way to help us remember everything we've seen. So it's 300 at 4 and at 7 it's up here. So let us assume that's the growth. That's 4, 7, and 450. So it's linear. We have to find a formula. You guys see the numbers?
Mm-hmm.
Yeah.
Yep.
Yeah, get going. Find the formula and then I'll do it so I to remind you it's linear.
I don't know if I did it right.
Okay, that's what I'm here for now, not on the quiz.
Oh, shit. I did it backwards, that's why.
Okay, so this is T, and that's the population. 4 years after they were released, we had 300 turtles. 7 years, we had 450. And scenario number 1, assume f of t is linear. And we're gonna find a formula. So let us remember, here it means that the formula is the slope mt plus b. That's the formula because it's linear. Let us compute the slope. What is the slope? So these are the y values, these are the x, but the t values. So the change in y, so it's 450 minus 300, that's the change in y, over the change in t, 7 minus 4. So that's gonna give me 150 over 3, which is gonna give me 50. Are you guys getting the same answer?
Yes.
Yeah.
Yeah. Now, that's the slope. Now I want B. Let us use the easy way. Let's find B. You can use the slope intercept or the point slope form. Let us use the slope intercept. Let us find B. We know that if T is 4, I have 300 turtles. So it means that if I plug in 50, I plug in 4 for T plus B is 300. Now I'm going to solve for B. It means 200 plus B is 300. B is 100. So the population would follow the formula f of t equal mt 50t plus 100.
Everyone outside?
Question? Please mute if there is noise in the background. Now, who would like to interpret the slope for me?
Every year, there's 50 more turtles.
Exactly. Every year, it's a constant amount. Every year, the number of turtles grows by 50 turtles. So the unit of the slope is turtle per year. 50 tells me that every year, the number of turtles increase by the same amount of 50. And the 100, what does the 100 represent?
The initial population of turtles was 100.
Of turtle. So graphically, now we know what the whole picture. Initially, if it's linear, if the growth was linear, it's 50. And then every t increases by 1, increases by 50. Sorry, that's 100. Increases by 50 is the same amount. Now, question number 2. Assume the growth is exponential. Find a formula for the population. Okay, so we're back to what we did last time, which is all right. And we're gonna find the formula now. assuming it is in exponential growth, set up the problem, and let's get going. We're gonna do it like we did it last time. And here f of t is, that's exponential growth. It's a times b to the t. How are we doing?
I don't know yet.
Anybody, you guys know how to start?
Yeah, you have to do a times b to the fourth equals 300.
Or 300. And the second tells me the other relationship between the a and b is a times b to the 7 equal 450. And I will do it. On the lecture note, I have two different ways. I'm going to do the one that, as I said before, was more intuitive for all of you. I'm going to solve for a. So it's going to give me a equal 300 over b to the power 4. I'm going to plug it back in here and get going. So I will have 300. I'm going to use this approach here. 300 over b to the power 4 times b to the 7 is 450. Okay? It means 300 b7 over b to the power 4 is 450. Now b7 over b4, as I said, is basically 7 and 4. It's 3 equal 450. Now I'm going to isolate my b, divide by 300 both. 300. And this is going to give me b to the power 3 equal, not
1 point.
What? 1.5?
Yeah.
1.5. So that's b to the 3. I want the b is the cubic root of that. And this is not a nice cubic root, so we're gonna go. And so I need 1.5, sorry. 1.5 to the power, I'm gonna open my parentheses, to the power a third, which is 1.1447. So let us 1.1447 for decimal to give us a good accuracy. So now I have my b. I have to go after my a. So I'll start a new page. So this is my b. Is 1.1447. And now I need my a. So I go back and see, okay, what's the relationship? What is my a? My a is 300 over b to the power 4, which gives me 300 over 1.447 to the power 4. You guys use a duet and see if you get the same thing as I do, because this way you know if you got it right or not. This time is up.
4.384.
Sorry, there's a 1. I forgot to put a 1 in here.
Oh.
Yes, my
Oh,
apologies.
okay.
Yeah, that's my. So it's 1.1447 the power 4.
0.716.
I got an answer. I want you guys to tell me what you got.
Yeah,
Put your answer on the chat. Those who got something, put it on the chat.
I only rounded to 3 decimal places, but that's what I got.
How much did you get? You put it on the chat. How much did you get?
You've forgotten my name, haven't you?
No, it's in front of me. It's Doran. I don't forget. That's the problem.
I got 1.716.
I
Didn't
don't
round
think
anything.
right. Christian, are you getting the
717.
same thing?
717, my bad.
Anybody else got something else?
No, that's what I got after I rounded.
I mean, did he start with 1 turtle? I'm getting 174. Anybody getting 100?
Oh, I didn't divide yet.
Doran, what did you get?
Yeah, I didn't divide either yet. That was just the bottom five.
Ah, okay. Okay, because
I know, I'm like, what?
Yes, all right.
174.723.
Right. Anybody else? 174. So we're gonna round it to 174.
That is what I
because
got.
there is no fraction of a turtle. 174. So the function is 174 times 1.1447 to the power 2. Okay, now my question to you is the following. What's the initial value in this model? So if they are growing exponentially, it means there were 174 turtle initially. And what's the growth rate?
1.1447.
So the growth rate is 0.1447. That's the growth rate. Because, let us remember what is the growth rate.
-5.
Because the growth factor,
Sleep.
that's the growth factor, is 1 plus the growth rate. So the growth rate is the growth factor minus 1, which is whatever, this is 0.1447, which is basically 14.47%. Okay. So now my last question was, and I'm out of time, I have to stop. My last question was, the biologists go back. In year t equal to 12, the biologists estimate that there are 900 turtles in the wetland. What does this indicate about population model? Was it more linear or exponential? How do you think you will answer this question?
Linear.
Why?
The number is really nice.
It'd be 700 turtles if it was linear.
Totally disagree. Linear, what was the formula for it?
Linear was, where the heck is that?
There'll be 7x
It was
plus 100 turtles.
50x plus b. No. Oh.
Yeah.
Don't let me say
50
anything.
plus b. Exponential, it was 174 times 1.1447 to the power t. And the biologists realize at t equal to 12, we have 900 turtles. So how can you tell which model is better? And we stop.
I've just plugged 12 into both of the equations.
Exactly. We plug 12 here and 12 here. And we ask ourselves, which one is giving me close to 900? One of them or neither? If neither of them, it means both models are not right. So I'm gonna plug this. So linear, if I put 12, I'm gonna get 100 plus 50 times 12. It's gonna give me 700 total. Now, let's see if this one is better. The other one is giving me 1,700, 4 times 1.1447 to the power 12, which is 880.
Dang, I was wrong.
So it means absolutely his model was in exponential growth. And usually population growth exponentially, not linear. Always population, whether it's turtle or humans or everything, it does not grow by the same amount every unit of time, by the same percent. So population always grows, usually exponentially. Okay, at this note, we stop. I think I went way over time. I'm sorry for that. Please do the homework. I will write up the solution for the worksheet I gave you from last time so you guys can check your work. And please meet me on my office hours. And if you cannot during my office hours, just send me an email, tell me, can we have a meeting some other time? And I can set up a meeting some other time. Okay, go have dinner. Good night, guys.
Good night.
Thank you.
Sure, bye-bye.